Okay, so everybody, this is the last lecture, endocrine system. You know that endocrine system is one of two control systems of your body, right? Nervous system and endocrine, those are two control systems. And endocrine system consists of endocrine glands. So first we'll talk about the properties of endocrine system. Okay? Then we'll see the important endocrine glands and their locations in the body. The most important endocrine gland, which is called the master gland, is the pituitary gland. You know that, right? And pituitary gland controls the other endocrine glands. That's why it is called the master gland, right? But pituitary gland is controlled by a brain structure that is called the hypothalamus. So hypothalamus controls the pituitary secretion. So we'll see how the hypothalamus talks to the pituitary gland, controls the pituitary gland. Then we'll talk about the pituitary hormones. Pituitary gland secretes a number of hormones. Pituitary gland has two parts, anterior and posterior. Anterior pituitary secretes 6 hormones and posterior pituitary secretes 2 hormones. So we'll see what are those anterior pituitary hormones and posterior pituitary hormones. Then we'll talk about the regulation of endocrine secretion, how the secretion is regulated or controlled. Then we'll talk about the important endocrine glands, other important endocrine glands, and their functions. So, endocrine glands are different than the exocrine glands. How the endocrine glands are different? If you see an endocrine and an exocrine gland, this is the endocrine gland. Okay? And this is an exocrine. Two types of glands we have. We are talking about endocrine today. So how the endocrine glands are different than the exocrine glands in your body. These are the cells inside the gland. So these cells produce hormones and secrete the hormones, where in the interstitial space. So these cells secrete hormones in the interstitial space in between the cells. Okay? Then from there, hormones enter into the capillaries. You know, blood capillaries are everywhere in the body, right? You know that. So, the hormones, these molecules, enter into the capillaries. Blood capillaries. And once the hormones enter into the blood, it goes everywhere. Make sense? Because blood circulates everywhere in your body, right? So, the cells of endocrine gland secrete hormones into the interstitial space first, and then from there goes into the capillaries. That means into the blood, right? And blood takes the hormones throughout the body. In case of exocrine, you see what happens. The cells secrete the hormones directly into the ducts. You know, ducts are tube-like structures, right? So these are the ducts, small ducts, tube-like structures inside the exocrine gland. Then these ducts get together, okay, and they join together and form a large duct, and that large duct just goes to the outside and release the hormone molecules or hormones to the outside of the gland. It doesn't go to the blood. It does not enter into the blood. So the cells secrete the hormones directly into the tubes, ducts, okay? Not in the interstitial fluid or blood. And the small ducts combine to form large duct, and that large duct just gets out from the gland and release the hormones to the outside. So this is how the exocrine system or glands work. So now if I ask you, tell me in which case the hormone will go everywhere to your body. Endocrine or exocrine? Endocrine, because going to the blood, right? So blood circulates everywhere. So generalized action, I can say, right? More generalized action. Which one releases the hormone just outside of the gland? Exocrine, right? Just outside of the gland. So it will act locally. Is it clear? Just will work here because it's not going to the blood. So if I ask you, tell me a few differences between endocrine and exocrine, I can say in case of endocrine, number one, hormones secreted in the blood. First, in the interstitial space, of course you can mention that hormones are secreted in the interstitial space. Interstitial space, then goes to the blood. So this action is generalized. Action, more widespread. And the target could be far. Target could be far from the gland because, for example, pituitary is in the brain. That hormone enters into the blood. That hormone can work to the distant organ. Makes sense? Because blood can take it far away. In case of exocrine, secreted hormones are secreted into the duct. Localized action, just outside of the gland. Okay? Near the gland. Okay? So those are the differences between the endocrine and exocrine systems. Important endocrine glands of your body. If you start from the head, part in your brain, you have two important endocrine glands, pituitary and pineal. Both start with P, right? Then here, in the lower part of your neck, you have the thyroid gland. Okay? Then, in the back of the thyroid, you have parathyroid glands. How many? Anybody remember parathyroid attached to the back of the thyroid? 4 to 8, right? 4 to 8 in number. Then, pancreas. Remember, pancreas is a mixed type gland. It is not purely endocrine, not purely exocrine, because it has both endocrine part and what? Exocrine part, right? since we are talking about the endocrine system, the endocrine part of the pancreas is called pancreatic islets. The endocrine part is called the pancreatic islets. Then on the top of your kidneys, you have adrenal glands, also called suprarenal glands, right? Supra means above, renal means kidney. So suprarenal or adrenal glands. How many? 2, because you have 2 kidneys, right? And they are sitting on the kidneys. If you go further down, gonads. Male gonads are testes, female gonads are ovaries. So 2 testes in male, 2 ovaries in female. Those are also glands because they produce and secrete what? Sex hormones. So they are also glands. So these are important endocrine glands. There are more, but these are the important ones. You see the location of those glands I have already mentioned. One gland I didn't mention, not listed here, that is called thymus. Thymus is located below the thyroid. Here is the thyroid, and below the thyroid, that means in the upper part of thorax, here. In infants, if you see the thymus, it is very big, occupies almost the whole upper part of the thorax, like this, in infant. But as you know, we get older, the thymus shrinks and becomes like this size, and it stays here. Now, hypothalamus controls the pituitary, right? I said that pituitary is the master gland, but pituitary also has a boss. Who is the boss of pituitary? Hypothalamus. Okay? So, hypothalamus is sitting just above the pituitary gland and controlling its secretion. How hypothalamus talks to the pituitary gland? This is the hypothalamus and this is the pituitary. So this is hypothalamus and this is pituitary gland. Pituitary has 2 parts I mentioned, anterior and posterior. Okay? Anterior pituitary produces 6 hormones and posterior 2 hormones. We'll know what are those hormones. Just know that hypothalamus controls the anterior and posterior pituitary. How? These are the neurons in hypothalamus. Hypothalamus is a part of the brain, so these are the neurons. And these are the axons of these neurons. These axons go to posterior pituitary, and the bundle of these axons is called hypophyseal tract. Tract is the bundle of fibers, you know that. So this name is long, but it is easy. This is hypothalamus, right? And another name of pituitary is what? You know that. Hypophysis. Remember that? Hypophyseal fossa. Pituitary sits there, right? So hypophysis is pituitary. So this tract or bundle of fibers or axons is called hypothalamo-hypophyseal tract. Make sense? Hypothalamo-hypophyseal tract. And this tract carries the signal from the hypothalamus to posterior pituitary. Brings the signal here and tells the posterior pituitary to secrete the hormones. Is it clear? Now, how the hypothalamus talks to the anterior pituitary. You see, these are the capillaries, capillary plexus, network of capillary, and from there, the blood vessel goes to the anterior pituitary, and another capillary plexus is here. So, the hypothalamus secretes chemicals into the blood here, into the capillary, and that blood brings the chemicals here and releases here, and that chemical controls the anterior pituitary. So, this is called portal system. Portal system is the blood vessel that connects two sets of capillaries. Here you see two sets of capillaries are connected by this blood vessel. That's why it is called portal system. One set of capillary is in the hypothalamus, another is in the anterior pituitary. So chemicals are secreted here. That chemical or signal molecules by blood is taken to the anterior pituitary, and that chemical controls the secretion of anterior pituitary. So this is called, again, hypothalamus, hypophyseal portal system. Okay, so that's how hypothalamus talks to the anterior pituitary by the blood. Okay, now we'll see the hormones. Here you see 6 hormones are produced by the anterior pituitary. Growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone or ACTH, follicle stimulating hormone FSH, luteinizing hormone LH, and prolactin. You need to remember these names, 6 hormones of anterior pituitary. Okay? Posterior pituitary produces only 2. Antidiuretic hormone or ADH and oxytocin. So those 2 are the posterior pituitary hormones, oxytocin and antidiuretic hormone. First, growth hormone. Its name is telling you. Have you heard growth hormone? I think all of you have heard growth hormone, right? Very commonly used in biotechnology to grow the animals first, right? Or crops. So, growth hormone helps in growth of the body. Very simple. Particularly, remember, growth hormone works on all the tissues, all the organs of the body and help in its growth, but in 2 organs or 2 structures, the action is more prominent, skeletal muscles and bones. Growth hormone action is more on the skeletal muscles and the bones. And you know those 2 things mainly help to grow the body, right? Growth of the bone, growth of the muscles. Thyroid stimulating hormone. Its name is telling you this hormone will go to the thyroid gland. So from the pituitary here to the thyroid gland, right? And will stimulate the thyroid gland to release thyroid hormone. So its name is telling you adrenocorticotropic hormone. Now you tell me, it will work on which gland? Adrenal gland, right? It's telling you adrenocorticotropic hormone. Now why it is called corticotropic? You see, this is the adrenal gland sitting on the kidney, and adrenal gland has 2 parts. Outer part is the cortex and inner part is called what? Medulla. So now you tell me, this name is telling you this hormone, adrenocorticotropic hormone, works on which part of the adrenal gland? cortex, right? That's why it is called cortico. Adrenocortico, it's telling you works on the adrenal cortex, right? Follicle stimulating hormone and luteinizing hormone, FSH and LH. Just know that these two hormones work on the gonads, testes and ovaries, okay? And help in the maturation of the sperm and ovum. Follicle stimulating hormone and luteinizing hormone. And also these two hormones in female help in ovulation, regulate ovarian cycle. Very important. These two hormones also regulate ovulation and ovarian cycle in female. Prolactin works on the mammary glands, female breast, and help in the production of milk. Posterior pituitary hormones are oxytocin and antidiuretic hormone, right? Oxytocin is a very important hormone. I will just mention a couple of functions of oxytocin. Number one, it causes uterine contraction of uterus. Get it? When you need uterine contraction? During childbirth, right? Uterus must contract very forcefully, right? So, during that time, oxytocin is secreted a lot, and that causes the contraction of the uterus during labor or childbirth. So, it helps in childbirth. Number two, oxytocin also helps in the ejection of milk. When the mother feeds the infant or baby, ejection of milk is helped by oxytocin. So those are two very important functions. Antidiuretic hormone, its name is telling you its function. But first you need to know, did you hear diuretics? I believe you have in newspapers, sometimes in magazines we read, right? Diuretics. Diuretics do what? Right. Produce more urine, right? Diuretics produce more urine. Have you heard that? Okay. So antidiuretics will do what? Produce more or less? Less, right? Anti, just opposite. So now you know antidiuretic hormone will produce less urine. Make sense? Stop production of more urine. Is it clear? So you know we say that coffee is a diuretic, right? That means it produces more urine. So, and that's a natural diuretic, right? So antidiuretic hormone acts opposite. So if more antidiuretic hormone is produced or secreted from the posterior pituitary, the volume of urine will be what? Less or more? Antidiuretic.
Inside your body or out?
Whatever, if more is produced inside, out will be more. Less is produced inside, out will be less. So antidiuretic hormone will produce less urine, right? Less urine. So the volume of urine will be less. Is it clear? Now you tell me, if any tumor grows in the posterior pituitary and that stops the secretion of antidiuretic hormone, then the person will produce what? Lot of urine. Make sense? Because antidiuretic is not being produced. Make sense? So person will pee a lot, right? Frequently, and more urine will be produced. And that clinical condition is called diabetes insipidus. Diabetes insipidus. Okay? It's not related to insulin or sugar. It is related to the production of urine and related to antidiuretic hormone, not insulin. Anyway, so those are two posterior pituitary hormones. Growth hormone works on all the organs or tissues of your body and help in the growth of those organs. So now you can think that during the growth of the body, right? When the body grows, growth hormone secretion is very important, right? To grow the body parts. But in two structures, the action is more, I mentioned, right? Which two structures? Skeletal muscles and bones, because those two organs help to grow the body mainly. But it also works on other organs of your body. Now, during the growth of the body, when the body is growing, that means in early stage of life, if growth hormone secretion is more than normal, normal is needed, right, for normal growth. If growth is more than normal, then the person will become what? Grow very fast, right? So it will become giant. And that condition is called what? Gigantism or gigantism. Gigantism or gigantism. So, excess secretion of growth hormone during when? The growth of the body. Is it clear? If growth of the body, ossification is completed, bone formation is completed, right? Bone growth is completed. Then if after that growth hormone secretion occurs more, bone cannot grow anymore, right? In length. But what will happen? Some bones of your body will grow in width. Because fusion has been occurred, right? Ossification is completed. In that case, growth will be sideways in width. And that is called acromegaly. Okay, acromegaly. So, if growth hormone secretion occurs during the growth of the body, that means early part of your life, then giantism or gigantism. Is it clear? Now, if that person's growth hormone secretion was normal during the growth of the body, the growth will be normal. And if for some reason growth hormone secretion occurs more after the puberty, that means in adulthood, bone will not grow in length anymore, but some bones, particularly the facial bones and the bones of your finger bones, will grow in width. Make sense? So, that condition is called acromegaly. In acromegaly patient, we see protruded mandible. Since the mandible grows, gets bigger sideways, protruded mandible, and also fingers are thick, big fingers. So you see here, acromegaly. Now, if the growth hormone secretion is less than normal during the growth of the body, the person will not grow enough. Make sense? So that condition is called what? Dwarfism. Dwarfism. During the growth of the body, if the secretion is less. Okay. In gigantism or giantism, the problem is, as I have mentioned, the hormone not only works on the skeletal muscles or bones, also work on other organs of the body, right? So the heart will be what? Bigger than normal, right? The liver, other organs will be bigger than normal, right? And that is a problem. Normal size of the heart is important, not big, not small, okay? So if the organ is larger, that organ functions less, malfunction, abnormal function, okay? So the patient suffer from multiple complications, including diabetes mellitus. Almost in all gigantism patient suffers from diabetes mellitus, okay? And the lifespan is shorter than normal average people. So gigantism people, they live shorter than longer normal people. This is a very famous picture. Many textbook, when I was a student like 30 years ago or more, in my textbook I saw this picture too. So this is a famous picture, and this guy is from East St. Louis, okay? And see everywhere in the world this picture is used, okay? This is a gigantism condition. How the endocrine secretion is regulated. Just know that endocrine secretion is controlled by negative feedback mechanism. You already know negative positive feedback mechanisms. What happens, you know, we already know hypothalamus sends signal to the pituitary, right? And pituitary releases the hormones, and that hormones work on the other glands of the body, right? For example, anterior pituitary releases thyroid stimulating hormone. We know that works on the thyroid gland, stimulate the thyroid gland will release thyroid hormones, right? And in the blood, the thyroid hormone concentration will go up, right? Because thyroid hormone is releasing thyroid gland is releasing thyroid hormone into the blood. So blood concentration of thyroid hormone will gradually go up. And at one point, when it will reach to an optimum concentration, what will happen? Negative signal will go to the pituitary as well as to the hypothalamus. It's shown by broken line. Negative, right? Inhibition is going to the anterior pituitary as well as to the hypothalamus, and telling them that don't secrete or send signal anymore because I have enough hormone already, right? So the secretion will be stopped. So that is called negative feedback mechanism. I have already talked about the oxytocin, antidiuretic hormone, prolactin. Thyroid gland. Thyroid gland is located in the lower part of the neck, front of the neck here, and it has two lobes. So thyroid gland has two lobes. This is one lobe, this is another lobe. These are called lateral lobes and connected by isthmus. So this is isthmus connecting two lateral lobes. So that is the thyroid gland. Thyroid gland produces three hormones. T3, also called triiodothyronine. Tri means three, you know, so triiodothyronine. And T4, also called tetraiodothyronine. Tetra means four, you know that. So I think triiodothyronine and T4 or also called tetraiodothyronine. Okay, or thyroxine. So T3 or triiodothyronine, T4 or tetraiodothyronine or thyroxine and calcitonin. So T3, T4 and calcitonin. Those are three thyroid hormones. Inside the thyroid gland, if you see inside, there are many finger-like structures. Those are called follicles. Look like this. These are called follicles, filled with follicles. And in the wall of the follicles, you have the cells. These are the follicular cells in the wall of the follicles. And in between the follicles, you have another type of cells in between the follicles. These are called parafollicular cells, not in the wall but outside of the follicle. So two types of cells, follicular cells and parafollicular cells. Follicular cells produce T3 and T4 and parafollicular cells produce calcitonin. Now let's see, if I make a cross section here, just make a slice and take a slice out, I'll see what? I'll see the follicles like this. So these are the follicles, right? The wall of the follicles, you have the follicular cells. So these are the follicular cells, and in between the follicles, you have the parafollicular cells. Okay? So these are parafollicular cells, right? And these are the follicular cells. Follicular cells. And these are the follicles. The round structures are the follicles, right? Now, inside the follicle, you have lumen. These are finger-like structures like this. If I cut it, I'll see the circles and lumen inside. And these lumens are filled with a protein. That protein is called thyroglobin. It is a colloid protein. Colloid protein called thyroglobin. Okay, so that's the structure inside the thyroid gland. You have many follicles, and in the wall of the follicles you have the follicular cells, and in between the follicles, parafollicular cells. Follicular cells produce T3 and T4. Parafollicular cells produce calcitonin. And inside the follicles, you have a colloid protein. Okay? You see here, follicles, right? And these are the follicular cells, and in between, parafollicular cells. And you have that colloid inside the lumen. Okay? Thyroglobulin is the protein. Thyroglobulin, not globin. Okay, thyroglobulin is the protein inside the follicles. Now, T3 and T4. Just know that T3 and T4, these two hormones, are responsible for metabolism. You know, thyroid hormone is very much related to metabolic activities of the body. Okay, so thyroid gland controls the metabolism. T3 and T4 regulate the metabolic activities. And calcitonin is different. Calcitonin lowers the calcium in the blood. Lowers the calcium. So totally different type of functions. T3 and T4 what?
Control metabolic activity.
Metabolic activities, right? just know that T3 triiodothyronine and T4 tetraiodothyronine, right? Now if I ask you, in T3, its name is telling you, in T3, how many iodine atoms you have? 3. Is it clear? In each T3 molecule, hormone molecule, you have how many iodine? 3. That's why it is called tri. And in T4, how many iodine atoms? 4. Make sense? So that's the difference, T3 and T4, okay? So how the T3 is formed? 3 iodine atoms, and in thyroglobulin you have a amino acid. This is protein, so you know protein has amino acid, that is called tyrosine. Okay, tyrosine. So T3 is formed by 3 iodine atom and tyrosine amino acid tyrosine. T4 molecule is formed by 4 iodine atoms and tyrosine, same amino acid. Okay, so that's how T3 and T4 are produced. Okay, tyrosine is very important amino acid for T3 and T4. Hyperthyroidism, hypothyroidism. Probably you have heard, right? Commonly we hear the term hyperthyroidism, hypothyroidism. If thyroid gland produces and secrete more thyroid hormone, T3 and T4, that is called hyperthyroidism. Okay? If less secretion, that is hypothyroidism. Very simple. Right? Now, I told you, you already know by now, T3 and T4, these two hormones do what? Regulate the metabolic activities, right, of the body. So if T3 and T4 are secreted more, then metabolic activities of the body will be more. Is it clear? More metabolism in the body. Even when you are in resting condition, metabolism is more than normal people, right? Now you tell me, what are the signs of increased metabolism? You all know when you do exercise, right? Metabolism increases. So what happens in your heart? Blood pressure goes up or down? Up, right? Heart beats faster, right? Blood pressure goes up. Sweating occurs, right? So in normal resting condition, you see the patient's heart rate is higher, right? Blood pressure could be higher, right? And the person will be restless and sleepless, less sleep. The amount of sleep is always irritated. Okay, person is always irritated. So those are the signs: increased heart rate, increased blood pressure. Okay, less sleep and irritated personality. Now you tell me, if someone has prolonged hyperthyroidism for a long time, metabolism is always high, right? So the amount of fat in the body will be less or more? Less, because metabolism uses fat, right? So the person will be thin, will lose body weight. Make sense? Body weight will be less. So those are the symptoms of hyperthyroidism. Make sense? And body will be warmer, because more metabolism produces more heat, right? You know that. So that if you touch the body, it is always a little bit warmer than normal people. Okay? So those are the symptoms. Hypothyroidism is just opposite. The blood pressure will be low, the skin is cold, okay? Heart rate could be less than normal. So that's the hyposecretion or hypothyroidism. Now, hyposecretion can lead to two clinical conditions. One is called myxedema and another is goiter. Myxedema, the persons, particularly the face area, has puffiness in the face. Okay, you will feel that person has water under the skin. Okay, puffiness of the face. Edema, edema. Goiter is the enlargement of the thyroid gland. So, in hyposecretion, the thyroid gland will get enlarged, and that is called goiter. You can see from outside. If you go to any, third world countries like poor countries, kids don't get enough iodine-rich food. Make sense? So, lack of iodine or iodine-rich food can lead to goiter. So, you will very often see the kids have goiter. Here, you don't see many. Why? Why hyposecretion leads to goiter? You remember I said you need